ছেলেটাকে ফোন করে নাও না, ও নাহলে মধ্যখান থেকে জয়েন করলে অসুবিধা হবে। আর রেগুলার যে ছেলেটা জয়েন করে যাও। আবার মধ্যখান থেকে জয়েন করে আবার রিপিট করা। হুম। হুম। Just like see today, uh, we will do our Newton's law. Newton's law of motion. You can see that we have discussed the Newton's law of motion. Before discussing the Newton's law of motion, we have to understand the what is the requirement to understand the Newton's law of motion. Because you see, in the class 11, whenever we are going to study the Newton's law of motion, vector concept is most important. Concept of the vector. Just whenever I'm just going to see the two vectors are there already, we have discussed. Still, I'm going to give one basic thing. Just like this is a vector A, this is a vector B. And if the angle is between theta, then this is a resultant vector. By addition of the vector, we can write like this way: a square plus b square 2ab cos theta is the resultant of the vector. Combining these two vector, I can get this much of resultant. Okay. Okay, Saurabh, can you hear me? Saurabh? Okay, sort of. Am I audible? Na? You can hear me. Okay, fine, very good. একটু ওর সাউন্ডটা বাড়াও, একটু সাউন্ড, আমি ও কি বলছে শুনতে পাচ্ছি না, ওর সাউন্ডটা একটু বাড়িয়ে দাও। বেশ খুব বাড়াতে হবে না। সৌরভ, just tell me. Hello. Yes, ঠিক আছে। This voice is okay. Just I've increased your little bit voice. I was unable to hear your voice. Okay, that's why I told. Okay, now Saurabh, you can see um, yesterday we discussed error part, isn't it? Yes. So that part clear. Check that portion clear. You understood? You understood, Saurabh? No problem. Very good. Fine. Very good. Now see, just like now it's going to enter into that physics portion. That portion is vector portion. Vector portion. Okay. You can see that. Acha, Saurabh, you know what is vector is? Vector quantity. Huh. Right. The quantities which have both magnitude and direction. Very good. Just like displacement. Displacement is a vector quantity. Okay. Just like a person just moving from point A to point B, it is called displacement, AB. It is having a direction as well as a magnitude. It is having a direction as well as a magnitude. So the shortest path that we join these 2 points, that is called displacement. Okay. But if I just see that a person just moved from A to B like this way in a curved path, a person moved from A to B in a curved path. So if I measure the total path length, that is called distance. Distance মানে total path length. ঠিক আছে? Understanding my point? But displacement is the initial point and final point if I join by a straight line. That is called displacement. So displacement is a vector quantity, but distance is not a vector quantity because I cannot specify any particular direction for the distance. Distance is the total path length. Understood? Very good. If any confusion, immediately ask me. Now see, what the thing is that whenever we want, just like displacement, it is having a direction as well as magnitude. Similarly, force is also vector. Force I can apply force in a certain point. Force having a direction as well as magnitude. Acceleration having direction as well as a magnitude. Acceleration, you know. Velocity having a direction as well as a magnitude, isn't it? Yes. So these are the vector quantities. So now I want to just discuss, today we are going to discuss that thing, then how to add two vectors. How to add, like see, I'm going to having a vector like one vector. Let us think first we start from the displacement vector. You can see that a point A, a point B, a displacement has occurred, AB. A person has moved from A to B. Okay, Saurabh? Now from B to C, second displacement, B to C. Okay, so A to B and B to C, what should be the combination, Saurabh? Can you tell me? Final displacement is equal to AC na? The total displacement is equal to AC. Mane net displacement, final displacement. It is called resultant displacement. So actually speaking, I can write vector AB, displacement vector, plus vector BC, displacement vector, is equal to vector AC. Try to understand. Vector AB, vector BC, vector AC. You don't think that if the magnitude of the vector is 4, magnitude of the vector AB is 4, suppose 4 centimeter or 4 unit, magnitude of the vector BC is 3, then can I tell that 4 plus 3, 7, 7 mane AC? No. It is not that 4 plus 3, 7. Understanding, show dog? Huh? But geometrically, AB displacement and BC displacement combining, I am going to get AC. It is not only the magnitude addition. Only magnitude addition is possible for scalar addition. Suppose 2 gram plus 5 gram, 7 gram. Gram is a unit of mass. Mass is a scalar quantity. Mass has no direction. That's why 2 gram plus 5 gram, 2 plus 5, 7. Understanding my point? Just scalar, just magnitudes are added. But for the vector quantity, only the magnitudes are not added. This is an important concept. Okay, understood? Fine. Now, up to this, so this diagram you see AB and BC, what I'm going to get? AC. So, actually, by this triangle, I can represent the addition of the vectors. By this triangle, what I can represent? The addition of the vector. Okay. So how it is represented? Just like the displacement AB from A to B, it is starting from A ending at B. Then from starting from B ending at C. Okay. Then end point C and initial point A, if I join, this is going to give the addition, final addition. It is called triangle rule. What it is called? Triangle rule. Okay, very good. Now suppose the magnitude of AB, I know that, just like magnitude of the AB is this much, magnitude of the AB is this much, magnitude of the BC is this much. So we are going to add this to AB, just like I'm going to draw in a next page. This is A, B, C. Okay. Now we suppose AB is equal to A, means length of the AB is equal to A, length of the BC is equal to B. Okay, I am producing this AB line, dropping a perpendicular from here, because I want to find the magnitude of the AC. Magnitude of the AB is equal to A, suppose 5, 6. Understanding? Similarly, BC, B. So I want to find the magnitude of the AC. This is theta. Let us think. This angle is theta. Perpendicular drop. This point is E. Geometry, you understand now? Right. You can see that. In the triangle BCE, in the triangle BE by BC is equal to cos theta. Trigonometry, you know, na? Little bit trigonometry. Yes. Base by hypotenuse cos theta. So we can write BE is equal to, what is the value of the BC? Value of the BC is B, na? So B cos theta. Similarly, CE, perpendicular, divided by this hypotenuse. And perpendicular by hypotenuse, what is the same? Sin theta. So CE is equal to B sin theta. Take. Therefore, now I want to find the length or magnitude of the AC. So you can see, sort of, ACE is a right angle triangle. So AC square is equal to AE square plus CE square, isn't it? Very good. So AE means what? What is the AE? AB plus BE whole square plus CE square. AB, what is the AB? Means A. BE, B is what? B cos theta. Sort of understanding? Very good. Plus, what is the CE? Mane B sin theta square. Okay. That is the AC square. Therefore, I can write AC square is equal to A square plus B square cos square theta plus 2 AB cos theta plus B square sin square theta. Okay. So ultimately A square. So now I can take the B square common. If I take the B square, what is inside? Cos square theta plus sin square theta 2AB cos theta. That is equals to AC square, isn't it? Very good. So now AC square, finally I can write A square plus, this is 1 cos square theta plus sin square theta, mane B square 2AB cos theta. So AC is equal to root over of A square plus B square plus 2AB cos theta. Try to remember this formula. Two vectors are there, A and B, and this is the angle theta. Then the addition of the magnitude of the addition of these two vector is equal to, this is the formula. Check. Very good. Okay. Sure of you writing now? Just copy these things. Very good. Sure of one thing you see, this BC, okay, this length is BC. What is the magnitude? B. Okay. If I just copy this vector and put it here, just like here, I'm putting, just copying the vector, same magnitude and parallelly shifting. BC, suppose this point is D. Then I can write BC vector is equal to AD vector. AD vector and BC vector same. Whenever we write vector, suppose vector AB, we give a bar sign, a directed line segment in this way. That's because it is a vector quantity. Then AD vector is in this direction and BC vector same vector. That's why if I tell that AB vector plus BC vector is equal to AC vector, just previously whatever we have written in the this one, AB vector plus BC vector is equal to AC vector, isn't it? Yes. So same way, AB vector plus BC vector is equal to AC vector. Instead of writing BC, I can write AB vector plus AD vector is equal to AC vector, isn't it? Bas. So now you can see, Shora, this AD and this BC are parallel lines having same magnitude. And ABCD is a quadrilateral. It is a quadrilateral. A quadrilateral, opposite sides are equal and parallel. Then ABCD is a parallelogram. Right. So previously I told that triangle rule. Previously I told triangle rule. Now I am going to tell that parallelogram rule. What the parallelogram rule is telling? If any point, at a point, two vectors are acting, this vector and this vector. Okay. Then if I develop parallelogram like this way, then this diagonal, which is passing from the intersection of these two vectors, will give the addition of these two vectors. Not understood? Understood? Very good, very good. Like, see, just like I'm going to give an example. I'm going to give an example. Sort of. Suppose this is a river. This is a river. Okay. And the in the river, a boat is floating. A boat is floating. Okay. Floating in the water. A person in the shore is standing like this way. Another person is standing like this way. This person, the person 1, person 2. Person 2 is just pulling the boat with a string in this direction. And person 1 pulling the boat in this direction. So the boat is experiencing simultaneous two forces now. One force in this direction, another force in this direction, isn't it? Now, will the boat move in this direction? Or will the move in this direction? No, the boat is not going to move in this direction or in this direction. Ultimately, we can see that the boat is going to move in this direction. If I develop a parallelogram, with these two sides, okay, I'm creating. This is my boat. One force is this direction, another force is in this direction. Then just like, see, one force this direction, another force this direction. The resultant is going to act in the diagonal side. Similarly, one force in this direction, another force in this direction. Resultant force is going to act in this direction, in the diagonally. That's why boat will start moving in this direction. Understood? Very good, very good. Now, show of C, like if I see this diagram on a parallelogram, if this angle is theta, naturally this angle will be theta. Geometry, two parallel lines cutting. So if this is theta, this is also theta. Both are theta. So if this is A, this is B, this is theta, then the resultant by addition of the two vectors, that should be a square plus b square plus 2ab cos theta. That's same formula. Same formula. So either I can prove this formula in the triangle rule, but I can also prove this formula by parallelogram rule. Same thing will come. So this is parallelogram, that's why it is called parallelogram rule. Sort of any confusion? Very good, very good. Sort of, see, if the two vectors are what I can tell, if the two vectors are parallel with each other, what is the angle between them, Choro? What? Angle is 0. If this vector is inclined, then I can get the angle. Okay. But if they're parallel, then there will be no angle, angle 0. Okay. Then I suppose this vector A, this vector B, then the addition by resultant of the two vectors are a square plus b square plus 2ab cos 0. Therefore, the R resultant value is equal to cos 0 mane 1 to a plus b whole square মানে simply a plus b. So if two vectors are parallel, then the addition of the vector is going to become simply scalar addition, just like. Understood? Because angle between them is 0 and value of the cos 0 is equal to 1. You know na, cos 0 mane 1. Very good, very good. Now can you tell me, Saurabh, if two vectors are oppositely directed, one vector this direction, another vector this direction, suppose this vector a, this vector b, opposite, there, তাহলে angle, what should be the angle? 180, right? Therefore the resultant addition of the two vector is equal to a square plus b square plus 2ab cos 180. Sure of you know the value of the cos 180? It has the value of -1. So you can consult the, have you started the trigonometry, Saurabh? Yes. So cos 180 মানে -1. You can just see. তার মানে a square plus b square. I put the cos 180 মানে -1 মানে -2ab. So therefore it can be written as r is equal to root over of a minus b whole square মানে r is equal to a minus b. Bas. It is the resultant subtraction of the two vectors. Simply magnitude subtraction. If the two vectors are oppositely directed, this direction, I can tell this one. This is the r mane a minus b. Okay. Very good. Now Saurabh, see. Acha, can I change the page? Very good. Now see, if the two vectors are mutually perpendicular with each other, a vector a, vector b, then this is the addition of the two vector diagonally. What is the angle between them? 90 degree. Parallelogram, na? So this angle between the two vectors is equal to 90 degree. This is, if this is r, মানে resultant is r, addition is r. So I can write a square plus b square 2ab cos 90. What is the value of the cos 90, Saurabh? 0. Right. So therefore r I can write root over of a square plus b square. But okay. Very good, very good. So these are the things. Okay. So just remember, these are some applications we have seen. We have to do these things. Okay. So now you can see, if the two vectors I want to get subtracted, because up to this point we are seeing the addition of the vector. Now just if I want to see the subtraction of the two vector, let us see. I have a vector a and this vector b. Okay, vector a, vector b. Okay. So this one is what? Vector a plus b diagonally. Okay, fine. Now if I want a minus b, vector a minus b, I want to get this thing, vector a minus b. So what to do? I have to put the b in the opposite direction, like this way. This is oppositely directed b, that's why it is minus b, na? Right. Now with the a and this minus b, if I create another parallelogram, this is a and minus b, if I just create another parallelogram, so this is the diagonal which is going to represent a minus b. Right. So understood. So this is the diagram of the a minus b. So can you tell me what should be the diagram of the B minus A? B minus A. But actually what to do? B plus of minus A. We are going to add minus A with B. Nothing else. So you can see I'm going to put the minus A in the opposite direction of the A. Minus A. Because plus A in this direction, minus A is in the opposite direction. Nah? Right. If any confusion arises, immediately tell me, Shora. Okay. So this is minus A. Therefore, plus B and minus A, this direction, this is going to become vector B minus vector A. This one like vector A minus vector B, this one, and this is vector B minus vector A. Thus, understanding na? Suppose, Saurabh, if the angle between A and B is equal to theta, angle between A and B is equal to theta, then angle between A and minus B will be 180 minus theta, right? Because this total angle 180. So if this is theta, so this should be 180 minus theta. Simple thing. Now, what to do from here? I want to get the magnitude of A minus B. This magnitude. Because vector A plus B, what is the magnitude? A square plus B square plus 2AB cos theta root. This one, magnitude. A square plus B square, magnitudically what? Root. A square plus B square plus 2AB cos theta. Already we have seen now how to derive this thing, that we have seen. Now we want to find this magnitude. Okay, so how to do? Simply you can see angle is 180 minus theta, therefore A square plus B square plus 2AB cos 180 minus theta. We just put magnitude of the minus B and plus B are same na? Magnitude. So we are putting only the magnitudes. Value magnitude of the A, magnitude of the B, the square, and 2AB. Then cos 180 minus theta. Then what the thing is going to come? You know trigonometry. Cos 180 minus theta minus cos theta. Plus, so therefore I am going to get A square plus B square minus 2AB cos theta. This is the magnitude of the vector subtraction. Understood? Very good. Any doubt or any confusion, Saurabh, whatever the discussions we have done up to this? No problem? Very good, very good, very good. Acha. Now see. I've changed the page, huh? Okay, fine. Now see, Saurabh, up to this point we have seen this thing. Okay, vector addition and vector subtraction. Okay. Now you can observe, Saurabh. If I want to add multiple vectors, what the process I have to apply? Multiple vectors, we just added two vectors, but it is not necessary that it is only two vectors. It can have 3 vectors, 4 vectors, 100 vectors. A lot of vectors can appear. We have to add more vectors. Okay, so that's why we are going to implement one of the most important concept, that is a component of vectors. Component, vector component. We are going to component of component of vectors. Okay. Now see, Saurabh, component money. What just I can tell, Saurabh? It's a part. It is a part. Just like I can tell 10 rupees. 10 rupees. I can tell 8 rupees plus 2 rupees is equal to 10 rupees, isn't it? So 8 is a part of 10. 8 plus 2 is equal to 10. When I can tell 8 is a part of 10. But 2 is also a part of 10. ठीक ना? Yes. Similarly, suppose I can tell a vector A, vector B, this is R. So I can tell R is equal to A plus B. So since A plus B is equal to R, I can tell A is a component of R. A is a component of R. Similarly, B is a component of R. Okay. Now, see what to do. Since I'm going to take the component of R, you can see if I'm just going to just spread this one, just elaborate this one. If I, from this point, if I drop a perpendicular here, from this point I drop a perpendicular here. If this angle is theta, then Saurabh, can you tell me this, what should be this length? This length? Just this length. Suppose this is x, then x, because this is a right angle triangle, isn't it? X by b is equal to cos theta. So can I tell x is equal to b cos theta? So you will see, Saurabh, b having, because this is the b, this vector is b, this vector is b, with the red mark I am showing. This vector having this component plus this component, isn't it? If any confusion, immediately ask me. So this vector, the vector b, is the addition of this vector plus this vector. This vector, this component vector is equal to b cos theta. This is x, b cos theta. Okay. So this b cos theta is acting along the vector a. You can see in this direction the a vector is existing now, and b cos theta is acting along a. Money, one of the component of the b is existing along a. Money, b is having a effect on a. So this is not a very required condition. Just like Saurabh, a person is doing his job, and any outsider coming and giving effect, it is telling you do this thing, you do this thing. But the person, whenever he was doing independently, he was satisfied. But whenever an external effect comes, he get disturbed. Understanding my point? Just like suppose if external person comes and he affects you. Saurabh, do this thing, do this thing. He instructs you. Will you like? You want to become independent. You study independently according to your decision. You do your job according to your decision. If anyone comes and interferes and gives the instruction, you don't like that thing, isn't it? Similarly, the vector A having an effect of the vector B, so A don't like that thing. That's why similarly there is a component of the A on B also. Just the component of the B is in the direction of the A. Similar manner, A having a component along B. So both are influencing each other. That is not a required thing. We don't like that thing. So the component of a vector should be in such a way they should be independent to each other. Try to understand, Saurabh. Component of the vectors should be in such a way they should be independent. They are not going to affect one another. Check. So what should be the solution? You see, just like the same vector r, I am going to take again this vector r, and I am splitting the r into two vectors. This vector r, this is a and this is b. Now you see, this is a vector r, one having component like this way, another component like this way, a and b. Two components are there. Now, but now these components are mutually perpendicular to each other. But previously, it was not 90 degree, it was not perpendicular. A and B were not perpendicular to each other. But in this condition, this angle is 90 degree. So now, in the previous case, the component of the B along A was B cos theta. Similarly, component of the in this case, component of the B along A will be B cos 90. What is the value of the cos 90? 0. Similarly, if I want to take the component of the A along B, what should be the component? A cos 90. So A cos 90 means what? 0. Therefore, I can tell B having a component 0 along A, means B having no component along A, but A having no component along B. Understanding, Saurabh? Therefore, they are independent. They are not affecting each other. So, this kind of components we are going to take. That component should be mutually at 90 degree with each other. Clear? Whenever we are going to split a vector into components, we must split the vector into mutually perpendicular components. Simple case. Check. Understood? Very good. Now see, if this angle is theta, because this is the vector r, vector r having a component along this direction, then a by r is equal to cos theta, isn't it? So like a is equal to r cos theta. Take similarly this one, b by r, but b is this much, by r is equal to sin theta. So b is equal to r sin theta. We can tell a vector, if I am going to split into two parts, just like vector r, this is theta, then this is r, we can tell this is r cos theta, and this one r sin theta. Bas. If a vector is existing and if any portion is making angle theta with it, so what should be the component? R cos theta. And with the this r cos theta, a component which is perpendicular to the r cos theta, that is called r sin theta. Sort of understood or not? Sort of understood? If still confusion, you ask me. Is that no confusion? It is clear properly. Okay. Very good. Very good. Now see. Just I am going to give an example from here. Okay. Okay. Acha Saurabh, you know, whenever I am just going to release an object from a top point, at a certain height, if I release, what is the acceleration with which it comes down? Acceleration due to gravity now, g. Yeah, very good. So now it is coming down and striking the ground. It is striking the ground. Okay. So suppose if the t time required to come to this ground, so what is the height it has traveled? H is equal to ut plus half gt square now. Have you seen that? S is equal to ut plus half at square. All these formulas were in the class 9, 10. Huh? Yes. So H is equal to half gt square. But if I release this object in an inclined manner, say, let us think it is an inclined plane, and I am going to release an object here. Very smooth surface, no friction is there. I am releasing this same object. I am releasing from here. The inclination with the ground is theta. Understanding my point? But diagram you understanding. It is an inclined plane, very smooth, without friction. I am going to release an object from here. Okay. So now, what is the direction of the acceleration due to gravity, Saurabh? Vertical, g, just like this one. Earth attracts the object downward, isn't it? So it is this way. Huh? Now, if I split because acceleration due to gravity, it is a vector quantity, I can split into the two components. Can you understand? Just like see, one vector I can split into two vectors. Like one vector I can split into this direction, isn't it? These two components are mutually perpendicular to this vector. But they are mutually perpendicular, this vector and this vector. Right? Similarly, if this is a vector, I can split into two components. They are mutually perpendicular with each other. This component and this component. Huh? Similarly, this vector acceleration due to gravity, I am splitting into two parts. One part in this direction, another part in this direction. They are mutually perpendicular with each other. Okay, very good. Now, simply geometry. If I take this one 90 degrees, this is theta. So, what should be this angle? 90 minus theta. Right? If this angle is 90 minus theta, this angle will be theta. Right? Geometry understanding. So this angle is theta. But this vector, just like simply this vector g is acting. G is having two components. This theta. So this will be g cos theta. Just like we have seen, this is r. So this will be r cos theta. This will be r sin theta, isn't it, Saurabh? The theta vector r making angle theta, so this component becomes r cos theta and this component become r sin theta. So this is g, so this is g cos theta, so this will be g sin theta. So this will be g sin theta. G cos theta, you see, this is a g cos theta. So because the object cannot move in this direction because it cannot penetrate that plane. This is perpendicular to the plane, isn't it? The object is free to come in this direction. It is free to fall in this direction. And what is the acceleration due to gravity now? G sin theta. It is not coming vertically, but in the inclined manner. That's why the acceleration, it is becoming G sin theta. Understanding that? So therefore, if it is moves for a certain time, suppose t1 time, it comes down to this ground, then the length it has traveled, this much of length, this much of length, this much of length, I'm just red color I'm showing, this much of length. So in the t time, if it is a traveling the t time, so what is the length? If the length is L, I can write half into g sin theta, because this is the acceleration, into t1 square. Is it clear, Saurabh? Very good. So now that the way I just have given this is the example simply. So this is the way we have to split a vector and we have to apply the components. which component is required in which condition, that we have to apply. ठीक? Very good. Now sort of see, by applying this by applying the concept of these components, we are going to add multiple vectors. Previously we have seen what? We have seen addition of the two vectors by parallelogram or triangle rule. But we are now applying, we will now apply to add three vectors. Three. Now see, Saurabh. Suppose one vector this way, another vector this way, another vector this way. Three vectors are there. Three vectors. Suppose vector A, vector B, vector C. Three vectors are there. I have to get the addition of the three vectors. Sort of understanding the question you understood. Okay, very good. Now see what to do from here. I am going to take a horizontal line. I am going to take a vertical line. Take this one x-axis. Take this one y-axis. Okay. Now take this angle. Suppose this is theta 1. Take this angle theta 2. Take this angle theta 3. Okay. Mane theta 1 is the angle, the vector A made with the x-axis, theta 2 the vector B made with the x-axis, and here also vector C made with the x-axis in this direction. Okay. Now Saurabh, if I split the vector A into two parts, what will be the two components? This component is equal to A cos theta 1, and this component kata A sin theta 1, isn't it? Right. Now if I split the B, this length, by red mark here I am showing this length, what will be the value? B cos theta 2, this much of length, and y component, this length, B sin theta 2, isn't it? Very good. Now if I split the C, this length, C cos theta 3, and this length, what is this length? C sin theta 3. So just we splitted the three vectors, first vector, second vector, third vector. I have just splitted all the vectors into x-axis and y-axis. Clear? Very good. Now see, Saurabh, in the x-axis, what are the components? A cos theta 1, B cos theta 2, and C cos theta 3 in the opposite. Check. Therefore, you can see, since these two vectors A cos theta 1 and B cos theta 2 are in the same direction, that they will be added, because we have seen the two vectors if in the same direction, parallel, same direction the parallel, but same direction. ठीक ना? So what we have to do for getting the resultant? We just simply add the. Sort of understanding or not? If not understanding properly, ask me. Understanding? Very good. So now x, final x, we can write A cos theta 1, B cos theta 2. But you can see, whenever I am observing the C cos theta 3, it is oppositely directed. That's why you are going to subtract C cos theta 3 minus opposite direction 180 degree. It should be subtracted simply, isn't it? So finally the total x, A cos theta 1 plus B cos theta 2 minus C cos theta 2. That's. Is it clear? Then y, what I can write? A sine theta 1, B sine theta 2, and C also in its upward direction. You can see A having component A sine theta 1, B having component upward B sine theta 2, and C is having a component upward C sine theta 3. So each and every one in this positive direction of the y, upward direction. So it should be added. So if I just do addition and subtraction of all these things, I will get the total x component and total y component which is existing along x-axis and y-axis. Therefore, if I just simply write this much of x, this much of y, what to do? X and y mutually perpendicular with each other. So resultant r is equal to root over of x square plus y square, na? Because 2xy cos 90 is 0. So the resultant, final resultant is like this way. Sort of clear or not clear? Tell me. Clear, na? Properly clear. Very good. So this is the how we can use the component concept to add the vectors. This is a way. This is a process through which we add vectors. Okay, fine, very good. Now see, Saurabh, just like we just applied the this component concept. Now I've changed the page. Now see, Saurabh, suppose I am having a vector A. We are going to define unit vector. Unit vector. Vector A. What is unit vector means? Just like unit means sort of one, isn't it? Unit means one. Okay? Just like if I tell 10 Newton force acting along east. 10 Newton force acting along east. Then if I show up tell, if I ask you what is the unit vector, what to do? Then I will tell we have to do 10 Newton force along east divided by 10. Mane the vector divided by magnitude of the vector. 10 Newton force along east divided by magnitude of the vector, mane 10 divided by 10, then 10 cancel out, it is going to become 1. So vector divided by magnitude of the vector will give us what? Unit vector. You see, this is vector A and its magnitude is written as like this way. I have to put 2 bars inside the vector. It is called magnitude of the vector. So therefore, vector A divided by magnitude, it is called unit vector, and unit vector has a symbol. It is written like this way, A cap. Cap is like this way. It is a pointed symbol. This A cap means it is a unit vector, and unit vector is acting, this much of unit vector acting along A. Sort of understanding? Sort of? Any confusion is there? Very good. So we understood what is unit vector. Tahole, how to get the vector? Vector can we get magnitude of the vector multiplied unit vector. You can see cross multiplication. Magnitude of the vector into unit vector. I will get the vector. Isn't it? Simple thing. Magnitude of the vector multiplied by unit vector. I will get the vector, actual vector. Okay. Now see, suppose we have a rule. We have a rule. What is the rule? Suppose I am going to say that this is my x-axis. In x-axis, we have a known unit vector, known. Everyone knows that thing. It is symbolized as I cap. I cap. I cap. Along y-axis, there is a known unit vector that is called j cap. J cap. Okay. So now, Saurabh, in the x-axis, if I tell a vector existing which is having a magnitude 5. In the x-axis, a vector existing, it is having a magnitude 5. So how can I write that vector? 5 I cap, because 5 is the magnitude multiplied by the unit vector, I will get the vector na. Just like a vector A is a magnitude into unit vector is a vector A. Similarly, the magnitude 5 multiplied by I, it is a unit, it is a vector along x-axis. Similarly, if I tell a vector, suppose I am writing this is a 4 I cap, and here y, I am having a vector of unit 3. So what is the vector existing here? 3 j cap, isn't it? So now, if I draw vectors along x-axis 1, 2, 3, 4. So this up to this vector is equal to 4 I cap, and 1, 2, 3. This vector up to 3 j cap. Well, finally, if I want to get the total vector, what kind of vector? Suppose a vector R, I am writing 4 I cap plus 3 j cap. 4 I cap plus 3 j cap. You can see this is 4 I cap, 3 j cap. Ultimately, I am going to get this one. This is R, isn't it? Bas Arki. So this is a way by unit vector I can get this kind of vectors. Sort of tell me, is there any confusion? This is the way we can represent a vector by I cap and j cap. Now we discuss the components na, like this one x components, this. So now simply we are doing also here. This is a 4 is the x component, 3 is the y component. Actually 4 I cap plus 3 j cap. Simply we are representing this vector. Similarly, Saurabh, if you just tell instead of if we write another vector is there, r1. Suppose I am telling that r1 is equal to 2 I cap plus 4 j cap. Suppose. So what is the component of the r1 along x-axis? 2. What is the component of the r1 along y-axis is equal to 4? So total addition, if I want to add two vectors addition, r1 plus r, what can be, what is the possibility? Because the x component is 4 in the r, and x component r1 is equal to 2. So if I add these two, 4 plus 2, 6 I cap, plus equals to 3 plus 4, 7 j cap. So only the components are added, nothing else. Just like previous one, you can see y means a sin theta 1, b sin theta 2, c sin, but actually we added all the y components, x, a cos theta 1, b cos theta 2 minus c cos theta 3, just added plus minus all the components along x-axis. Here also we are doing the same thing. Component along x-axis is equal to 4 I cap, is equal to 2 I cap. So that is added. Similarly, this are 3j cap, 4j cap. So this is added. So finally, addition of the vector in the component method, it is quite easier. The component method and using the unit vector process, it is more easier. So can you tell me, Saurabh, if I just going to give r is equal to 4 I cap plus 7 j cap, r dashed is equal to I cap plus j cap. Can you tell me vector subtraction r minus r dashed? What should be the vector subtraction? Huh? No, just like see, if I subtract r minus r1, the component 4 I cap minus I cap, 3 I cap, and 7 j cap minus j cap, 6 j cap. That's complete. Clear? So if I tell to add these two, r plus r dashed, bas, understanding na? Very good. Acha, if I have multiple vectors, suppose r1 plus r2 plus r3, r1 is this much, r2 is this much, and this is r2. Let us think this is r2, and r3 is equal to I cap plus j cap. Can you tell me what is the addition? R1 plus R2 plus R3. Bas, right. So understanding na? So if I just going to tell that R1 plus R2 minus R3. Right. Right. So understood na? Very good. So this is the way just we can add or subtract vector in the component form. Okay. So up to this point, so unit vector you clear. Okay. Acha. Saurabh, if you are asked, because you observe this is R 4 I cap plus 3 j cap, it is a vector R, isn't it? Now, can you tell me how I can find R cap? How can I find R cap? Unit vector along R. How can I find? The rule is that vector by magnitude of the vector is the unit vector. Vector by magnitude of the vector. Vector by magnitude of the vector is a unit vector. No, can you tell me what is the magnitude R? Because 4 is there, this is 4, this length is 4, this length is 3. So what should be the magnitude? Root over of 4 square plus 3 square. 5 na? Unit vector R cap means vector R by magnitude of the r na. তাহলে vector r means what? 4i cap plus 3j cap divided by magnitude is 5. So 4i cap plus 3j cap by 5, it is the r cap unit vector. Understanding my point or not? Understanding though? So this is the way we have to find unit vector. Just vector divided by magnitude of the vector, I am going to get unit vector. It is clear? Very good. Now see, I've changed the page. Any confusion up to this point? No confusion. Very good. Now Saurabh, see, another component is going to come, that is z-axis, because x-axis unit vector is I cap, y-axis is j cap, but if I take the z-axis, unit vector is called k cap. I cap, j cap, k cap, three-dimensional. Okay. Now see how to do this thing. Let us think that I'm going to draw this kind of structure. This is x-axis, this is the y-axis, that's it. Okay, three-dimensional. Three-dimensionally, it is a cuboid-like of structure now. Right. Suppose now, if I join this point, joining. This point is O. This point is O, and so this is the vector. Suppose this the point is P. OP is a vector. OP is a vector. Let us think this length is A. This length is A. This length, but this length A is along x-axis. But A is the component along x-axis. This length B, it is a vector along y-axis, and this length, it is a C along z-axis, vertical, upward. Okay. So what is the vector along x-axis? AI cap. What is the vector along y-axis? B j cap. What is the vector along z-axis? C k cap, isn't it? So if I add A I cap plus B j cap plus C k cap, I am going to get the OP vector. This is a three-dimensional representation of a vector. Clear? Very good. You can see the length along x-axis is A, length along y-axis is B, and length along z-axis is C, x, y, z. Okay. Now, actually speaking, in the cuboid, in this cuboid, whatever we have drawn, in this cuboid, OP is a diagonal, isn't it? Right. So, how to calculate the length of this diagonal, Saurabh? You know, formula was there in the class 9 mensuration. Length square plus breadth square plus height square. Remember? Length square plus breadth square plus height square root is the length of the diagonal. So now the magnitude of the OP is ultimately we can write root over of a square plus b square plus c square, isn't it? Bas or kya? Now can you tell me, Saurabh, what is the OP cap? Money unit vector along OP. Unit vector along OP mane? OP vector mane to this vector. AI cap plus BJ cap plus CK cap to. If I divide by magnitude, mod OP, I will get OP cap na. So what is the magnitude we found? This is the magnitude we found. Yes. The unit vector along OP is equal to vector by magnitude of the vector. Mane AI cap plus BJ cap plus CK cap divided by root over of a square plus b square plus c square. Understood? So this is called unit vector. If any vector comes, this is the method through which we can solve. The question will come in the school exam or any kind of exam. So finding the unit vector is it is important. Clear? Very good, very good. Okay, fine. Up to this point, it is clear. Okay, now, acha, Saurabh, you can see the vector OP is creating some angle with x-axis. It is also creating some angle with the y-axis. It is also creating some angle with the z-axis. Can you see? It's like this is the angle it is creating with the x-axis. Suppose alpha. This is the angle it is creating with the y-axis. Suppose beta. Isn't it? Sort of? It is also creating some angle with the z-axis. Suppose gamma. It is creating some angles. Okay. Now, suppose a line is there, just like previously what we taught. This vector, suppose this is the A. If some angle is created, what is this length? A cos theta, isn't it? If this vector is A, if the theta is created, so what is the component along this direction? A cos theta, na? Similarly, I can tell you that, what I can tell? This OP cos alpha is equal to A, na? This OP, this angle is alpha with the x-axis. So component of OP along x-axis is equal to OP cos alpha is equal to A. Similarly, OP cos beta, it is the component of the OP along y-axis. What is this that thing? This is a component cos beta. It is along y-axis. What is this length? It is actually we have taken the y. Actually, this will be z. Sorry, this will be z. Vertically, this should be z, and this should be y. Take this one. Change this one. This should be y. Okay. This is this vertical z. So now, this one just like A, I cap, B, J cap, and C, K cap. So this C, this is z axis, so C K cap. So this one, this OP, it is making the angle beta with the z axis, and what is the component is it is equal to c. OP cos beta is equal to along the z axis is equal to c na, the component along z axis is equal to c. Similarly, OP cos gamma, OP cos gamma, what is this length? B is equal to B. Is it clear? Up to this point it is clear. Now if I make the square of each and every one, if I make the square, OP cos square alpha, OP cos square beta, OP square cos square gamma is equal to a square plus c square plus b square. So I can take OP square, OP square, OP square. OP square I can take common. Cos square alpha plus cos square beta plus cos square gamma. We can write what? A square plus b square plus c square. ठीक? अच्छा. You can see this is OP square. This is OP square. And already we know, because from the class 9 concept, OP is the diagonal, and diagonal square, already we know, a square plus b square plus c square. Na? Best. So this is also OP square. A square plus b square plus c square is equal to OP square. So we can directly we can write like this way. This is equal to OP square. So this OP square cancelling out. So what is remaining? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Understood? হ্যাঁ মাতাজি বলুন, হরে কৃষ্ণ, ধন্যবাদ। না এখন তো করিনি আপনাদের, না এখনো কিছু জানাইনি। হ্যাঁ ওটাই তো আসল, টোটাল যে আছে যে, হ্যাঁ মানে হ্যাঁ ওরা কটা নিয়ে গেছে ওরাই ঠিক মতো জানে, মানে পেটিগুলো তো ওদের কাছেই পড়ে আছে না, পেটিগুলো যে কটা নিয়ে গেছে সে কটা ওদের অফিসেই পড়ে আছে। হ্যাঁ ওই 26টা 8টা প্লাস 37টা লুজ, কিন্তু তার মধ্যে ওটা একবার ওরা একবার দেখে গিয়ে বলে দিলে অফিসে কটা পড়ে আছে কাউন্টিং করে। হ্যাঁ মানে ওই টোটাল যতটা নিয়ে গেছে ওরাই কাউন্টিং করে বলে দেবে টোটাল কটা নিয়ে গেছে। আমি তো বলছি তো 26টা নিয়ে গেছে, তার আগের দিন 8টা নিয়ে গেছে, আর 26টার সঙ্গে 37টা লুজ নিয়ে গেছে, এটাই নিয়ে গেছে। যাই হোক ওরা একবার দেখে অফিস থেকে বলে, এখনো তো আমাকে কিছু ফোন করেনি। হ্যাঁ আমি বলবো, বলে আর একবার ওই যে ছেলেটি, হ্যাঁ হ্যাঁ আমি, হুম হুম ওটা নিয়ে মেসেজ করবো, ওনাকে মেসেজ করবো। হুম, ঠিক আছে, হরে কৃষ্ণ। তো সৌরভ, হ্যালো, this is clear. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is actually, it is a special what you can say, a property. And this cos alpha, cos beta, cos gamma, it is called direction cosine. This have a name. Cosine to cos, you know, cosine mane cos. And why it is telling direction? Direction mane With this angle, I am specifying the direction of this vector. That's why it is called direction. It is called a direction cosine. তার মানে summation of the squares of the direction cosines is equal to 1. Summation মানে addition of the squares of the cosines is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Clear? No problem. Very good. Very good. Fine. So up to this point, this vector concept, it is clear. I think so. This vector related concept, it is clear. ঠিক আছে. Very good. Now see Saurabh, just like we will just apply something. This concept of the vector we have to apply in the numericals, numericals of the physics. Okay. The I cap, J cap, K cap, all these things will come in the numericals. Okay. But how to apply? Dhire dhire we will understand how to apply this concept in the numericals. But first of all, we have to do something like some examples, just like sort of you can see that one-dimensional motion. In one-dimensional motion, Saurabh, you have to understand one thing that is called differentiation. Differentiation is the calculus part. Calculus is a calculus part. Okay. Calculus is most important tool, mathematical tool in physics. And we apply frequently. We apply frequently. Unless and until we apply this principle, it will be difficult for us to understand. So now we have a concept, just like limit concept. Limit concept. Just like if I tell x, I'm giving a symbol. The arrow symbol is there. Saurabh, understanding my point? Arrow symbol. Saurabh, understanding? I've just given an arrow symbol. Means what? X is tending to 1. Means what? It means what? It means x is never equal to 1. But x is extremely nearer to 1. Just like x can have value 1.00032. This number is very near to 1 now. But I can tell x is equal to 0.9999. This number is very extremely nearer to 1. So this concept is that whenever I am going to write this kind of thing, x tends to 1, mane x arrow 1, mane limit LIM, it is right, we write limit, ba LT, limit. In this way we write limit x tends to 1. It means x very near to 1, but it is not becomes equal to 1. Never it will become 1. This is a thing. This is a concept of limit. Simple thing. Okay. Similarly, you can see that function mane, suppose if I write y is equal to fx. If I write y is equal to fx, okay, it means y is dependent upon x. What I'm telling? Y dependent upon x. Okay, মানে suppose if I write y is equal to x square plus 2, y is equal to x square plus 2. So if you put x, some value of the x, then y will change, isn't it? If I just be putting x, some values of the x, and continuously y is going to get changed, I can get lot of y. So we can plot a graph of xy graph. If I tell y is equal to 2x plus 1. Saurabh, have you know this? Do you know this thing? Y is equal to mx plus c. It is a straight line equation. In the straight line equation, if I develop a graph y and x, I can see the straight line is like this way. M is the slope of the straight line, c is a constant. I think you heard this thing, no? In the 9 or 10, the straight line equations was there. So this is the thing. Now, when the straight line graph is possible, when the power of the x and power of the y both are 1, then the straight line graph will be straight line. But when the power 1, when y has the power 1, but x has the power 2 or something else, 3, 4, whatever, I cannot get a straight line. It will be graphed, just like, see, if I'm changing, if I tell y is equal to x square, I can, if I just plot a graph y and x, I can tell you that the graph is like this way. Actually, it is a parabola. This is a parabola. Okay. Similarly, lot of graphs we can have and function we can have. According to the function, we can draw or develop graph. Understood? I think you understood. So limit concept you understood, limit, and simultaneously you understood the function concept. From the function we can develop a graph, mathematical graph. Okay. Now see, just like if I develop what y and this is x, a graph is like this way. I have developed a graph. This point is P, this point is Q. Let us think. The P is having coordinate x1, y1. ठीक है? Q is having coordinate x2, y2. Okay. If I join by a straight line, so it is a chord, na? Chord you know to? It is a chord. Now, this length is x1, this length is y1. This length is x2, this length is y2. What the coordinates we have seen? x1, y1, x2, y2, isn't it? Now, if I drop a perpendicular, from P2 on this line, can you tell me, hold up, this length is also y1, this length? So this length is what? y2 minus y1. Not understanding? Got it? Very good. So this length y2 minus y1, and this length x2 minus x1. तार माने in the change of x2 minus x1, there is a change of y what? y2 minus y1. তাহলে we can write due to the change of x2 minus x1, what is the change of y? y2 minus y1. So due to the unit change, what is the rate of change of y with respect to x? I can write y2 minus y1 divided by x2 minus x1. Not understood? Just like see, I told you that due to the change of this much of x, this is the change of y. मैंने बोला suppose पकड़ो within 2 years you have earned 4 lakhs rupees, suppose. So due to the change of 2 years, 4 lakhs. For 1 year, what is earning? 4 by 2, mean 2 lakhs. Understanding? The same thing. Change of y by change of x. It is called rate of change of y with respect to x. Check. Isn't it? Very good. Now see, this y2 minus y1 divided by x2 minus x1 means what? If this angle is theta, if I produce this line, this is also theta. That means I can tell tan theta is equal to y2 minus y1 divided by x2 minus x1. This is called tan theta. And this tan theta is what? It is the slope of the straight line. This chord having a slope. The slope of the straight line, which is the chord of this curve. Okay. Now, Saurabh, see, if I bring the Q nearer to the P, what I'm telling? If I bring the Q nearer to the P, what the thing is going to happen? You can see when Q is moving towards the P, it is coming nearer to the P, y2 minus y1 becomes small, and also x2 minus x1 becomes small. Both the upper and lower, numerator, denominator, both are going to come very small. Then at the extreme situation, when almost Q, I can write limit Q tends to P, then I can tell delta x, this x2 minus x1, this x2 minus x1, I am telling that delta x, and this y2 minus y1, I am telling that delta y. Suppose let, then x2 minus x1, delta x will become extremely small, will tend to 0, limit delta x tending to 0. Isn't it? Then this ratio, which ratio? This ratio, y2 minus y1, I can tell delta y by delta x, limit delta x tending to 0. Delta y by delta x, limit delta x tending to 0. It is going to become slope of whom? Of this chord. But chord, I'm not going to get these two separate points, because when Q is extremely nearer to P, then this chord is going to become almost a tangent. It is going to touch in a single point. Sort of understanding my point? Almost 0. It is not 0. Tending to 0. Then if this is the delta x tending to 0, then this ratio, is going to become slope of the straight line of whom? Which straight line? Tangential straight line at this point, at the point P. Previously it was a chord, but now in this situation it has become a tangent. Tangent, you know, na? Tangent. When a straight line touching a curve in one single point. Tangent of a circle in the class 9 or 10 in the geometry. I think you've done. Saurabh? Is it difficult? It is not, na? Very good. Dale, this has become tangent at the point P, and the slope of the tangent is this much. This is called differentiation of y with respect to x. It is written as like this way. Differentiation of y with respect to x means rate of change of y with respect to x at the point P. How the y is going to change with respect to x? What is the rate with which the y is going to change with respect to x? It is called rate of change of y with respect to x. Understanding my point or not? Saurabh? But so this is the concept of the differentiation. Actually, differentiation means in the graph at a certain point, if I develop tangent, it is the slope of that tangent is the result of the differentiation. Yes. With the slope of the tangent, I can understand what is the rate with which y is changing with respect to x in that point of the graph. Got it? Very good. Fine. Now, Saurabh, I will tell you a formula. Try to remember. खूब simple formula. Ekdam simple formula. Suppose I am going to tell that y is equal to x to the power n. Then differentiation of y with respect to x. X to the power n. N into x to the power n minus 1. Remember this thing. Formula. Proof is not required now. Proof, just we are going to use this formula. Mane, suppose y is equal to x to the power 5. What is the value of n? Saurabh? 5. Value of the n is 5 in this situation. dy dx mane x to the power 5. What is the formula? N into x to the power n minus 1 mane 5. X to the power 5 minus 1 mane 5 x to the power 4. This is the result. Understood? Very good. Saurabh, you see, suppose any constant is multiplied with, suppose I am telling that 2x to the power 6. If I differentiate 2x to the power 6, then this constant will come out. 2 is come out. Okay. Then 6, with this formula, n into x to the power 6. X to the power 6 minus 1. Mane 12 x to the power 5. If I differentiate this one, I am going to get this one. Is it clear? Very good. Now, Saurabh, if only one constant number is there, if I differentiate, suppose a constant number, I am differentiating 2 with respect to x. You every time remember, if I differentiate a constant number, result will be 0. Because constant will never change. So, rate of change of constant will be 0. Check. Very good. Very good. Now see, suppose some multiples, acha, written these things, Shoda? Noted? Very good. Now show up, see, if I have y is equal to 2x square plus 4x plus 3, if this is the expression, if I want to differentiate, you can see 2x square is a separate function, 4x is a separate function, 3 is a separate. So whenever the y I have to differentiate now, separately differentiate all and add all these things. Then dy dx, differentiating y with respect to x, then differentiating this whole 2x square plus 4x plus 3, okay, differentiate this 2x square plus differentiate 4x plus differentiate 3, okay. Now this constant 2 is going to come out, differentiation of x square, isn't it? Constant 4 will come out, differentiate x, isn't it? And this 3 is only constant, so result will be 0, isn't it? Very good. Then 2 into, now formula, 2 into x to the power 2 minus 1 plus 4 power of x is equal to 1, mean 1 x to the power 1 minus 1 plus 0. তাহলে 2 to the 4, 2 minus 1 মানে x plus x to the power 0, x to the power 0 মানে 1, to the power 0 মানে 1, plus this is the result, 4x plus 4. If I differentiate y, I am going to get this much when y is having this much of value. Sort of, is it clear or not clear? Tell me. Clear? Very good. So this is the thing. Just these are the applications of the sort of differentiation. And the next day we will continue with the differentiation, as well as I will give you 1 or 2 examples in the next day, and after that we will continue with the integration. If you differentiation, if the integration is clear, immediately we will move to the one-dimensional motion, 1 and 2 dimensional motion, because we have to apply all these principles of integration and differentiation there. So it is clear, Saurabh, okay? Still, if you have any confusion or doubt, you can ask me. No problem. No problem, na? Very good. Very good. Very good. Check. Next day we will do the integration. Okay, Saurabh, today we will end the class. Okay. Okay, chalo. Hello.